Hey everybody. In this video we're going to be evaluating a quadratic expression. We're going to be doing that from function notation in any of the three forms of quadratic equation that we've seen. We can do this from vertex form, from standard form, or from intercept or factored form. If we're going to do this, we really need to remember what function notation looks like. So what you see here is I have a table of values. I have the same table of values presented in function notation, and then I have the expression for those values presented in function notation. So let's take a look at what we've got here from these values for function notation there. And notice I've color-coded them. The x and the 1 and the 3 and the 4 are all in orange. You can see that those come from the left-hand side of this table. The y, the 4, the 10, the 13, that's all in blue. You can see it comes from here. But that f is something that a lot of students struggle to understand what that means. So here's what that means. You see this table? This whole thing, that represents a function. And we name that function, in this case, f. So all that means is that we're looking at the x and y values. So the value in parentheses is a domain value, an x value, and the one in blue is a range value, a y value, but it's all for this function f. And I can name this anything I want, F, Mo, Larry, Curly, doesn't matter. It's just a name. And when I come down here, I've got the same thing going on, except that what's different is I've got my name of the function, f, I've got my domain value, the x value is there, but instead of just giving a y value, I give a recipe for it. So that is, if I know what x is, I can find the y value. So take, for example, this function f. When x is equal to 3, this expression gives me a recipe for finding the value of y. I take that 3 from there and replace the x with that. So when x is 3, I make the x equal to 3, and then perform the calculation. 3 times 3 would be 9. 9 plus 1 would be 10. And so I find that this whole thing, maybe I should write that from there, is 10 when x equals 3, which is just what we'd expect. So in order to find f of 3, that is the y value when x is 3, substitute it in and perform the calculation. So let's do that now for this example problem. Given the functions below, and you can see I have 3 of them. I have g of x, I have f of x, and h of x, remembering that f, g, and h are just names. I want to find f of 5. So that f tells me I'm dealing with this function right there. I can ignore all the others. And I want to find the y value when x is equal to 5. Well, this right here is my quote-unquote recipe for finding the y value. So here's what I'll do. I'll take f when x is equal to 5, and then my recipe, my formula, my expression, tells me to take 4 times whatever x is, 5 in this case, squared, plus x again, so another 5, minus 1. And now in order to find f of 5, all I have to do is evaluate that expression. So 5 squared means 5 times 5, and that's 25. And I copy the rest down. Notice I'm just doing one step at a time. 4 times 25 is 100. 100 plus 5 is 105. And of course, 105 minus 1 is 104, which tells me that f of 5 is equal to 104. Let's look at another. Now I want g of negative 1. So the g tells me that I'm looking at this function, and when the x value is negative 1, I can replace all the x values in that expression to find out what the y value is. So I would have negative 1 plus 2 squared minus 4. Notice again, I'm writing down every step. I don't want to lose anything in between here. So first I would evaluate everything in parentheses. Negative 1 plus 2 would of course be 1. Then, this is just order of operations. Parentheses, then exponents. 1 squared would of course be 1. This means 1 times 1. And negative 3 times 1 would be negative 3. And when I take negative 3 minus 4, I am going to get negative 7. So g of negative 1 is negative 7. Finally, let's take a look at finding h of 3. The h tells us that I'm dealing with this function. And in order to find h of 3, I take my expression that is going to tell me how to find the y value, and I replace every single x with a 3. And then I simply evaluate using the order of operations. So the order of operations tells me I would do everything in parentheses first. So inside this first set of parentheses, I have multiplication and addition. Multiplication comes first, so I do 2 times 3, which is 6. And again, notice one step at a time. And don't forget about your negative sign out front. That would be easy to miss. 6 plus 3 is, of course, 9. And 3 minus 5 is negative 2. Notice I am multiplying those because the parentheses are right up against each other. And 9 times negative 2 is negative 18. That leaves me with negative 18, or the opposite of negative 18, which of course is positive 18. So h of 3 is equal to 18.